So we're going to look at factoring polynomials. So far, we have been working with polynomials and multiplying monomials to binomials and trinomials and binomials to binomials and so on and so forth. So we know how to do it that way, but now we're going to kind of do the opposite, so the inverse of the multiplication, which is to factor out the polynomials. So hopefully you have watched the video that I shared. I like the video. I like that he talks about the two smiles method. It's a lot easier than the way I learned it. So I'm really happy he shares that method with you. He gets into the more complex polynomials, and we don't really factoring of those polynomials, and we're going to hit that a bit, but it won't be too much, so don't be, if you're overwhelmed by it right now, don't worry. We're going to start out slow and build, and if you do understand it, that's awesome. I'm really happy because it is big. It's a big jump again, and but moving on from the skills that we've already had, and we're just building on skills. But now we have to kind of go backwards. So I'm gonna go back a little bit just in case that we forgot how to find the greatest common factor, because that's the start, and that's really what we need to do with these polynomials when we're factoring them. The very first step is to find the greatest common factor, and he talks about that in the book. I mean, in the video, and also in the book too. So you guys should all have that chapter 15. Factoring polynomials, and that's from my algebra book, and if you read through, it will tell you finding the greatest common factor, and that's really where we're going to start. So, and that's the homework that I put up for due on Friday, not this Friday, March 27th, I think is the date. Yeah. And so just keep an eye on that. But so here I want to start with just the basics of finding the greatest common factor, and just so we remember how to do that. So I'm using this really fun tool right here, and bear with me, I'm still learning, and I haven't done this in a very long time, and of course technology constantly changing on us. So anyway, so this is, let's say we're finding the greatest common factor of two numbers like 12 and 18. Hopefully you're already know how to do this, and you're kind of instantly going, oh, I know, yeah, I see it. I know what the 12 and 18 greatest common factor. So I'm going to look at the factors, and I'm going to factor out 12. So what are the factors? Well, the factors are all the numbers that we multiply together to get 12, or we multiply together to get 18, just so you know. Those are, and we're looking common factors, or whatever numbers that they share when we do this, finding the roots. I like to say these are roots out of the number, and so obviously 12 and 1, and 18. Well, I'll just do 12 first. 12 and 1, and then I know I can do 2 and 6. 2 times 6 is 12. I know that 3, or I could put 1 here. I should have probably done that, sorry. But anyway, hopefully you're following along, it's fine. 3 times 4 is 12. And then it's 4 times 3, and so on. Did I miss anything? 3, 4, 6 times 2. Yeah, okay. And then we'll look at 18. So 18, it'll be 1. I'll just do it that way. 1 and 18. 1 times 18 is 18. What about 2? Yep, it's an even number, so 2 times 9. And I can do 3 times 6. And then it goes backwards, 6 times 3. 8, 9, 9 times 2, 8, 2, okay. So now I'm looking for the greatest common factor of these two numbers. And I see that they have, well, they have 3 in common, don't they? And they have 2 in common. Those are 2 common factors. And then they have, oh, this 6 and 6. So which is the highest of the common factors that they have? I mean, I could circle 1, 2, but every number is going to have 1 in common. So I'm going to ignore that for now. And yeah, 6. So the greatest common factor is 6. And so 6 is our GCF. If you're struggling with this, let me know. And we can go backwards. Or I can put up a video again of how to find the greatest common factor amongst numbers, what they have in common, if you need that. But otherwise, I want to move on to getting into algebra, where we're finding the greatest common factor with polynomials and the use of algebra. So I'm going to erase this now. Look at the bouncing ball. Follow the bouncing ball. Yay! We're racing. Oh, I erased. Well, you know what it is, factoring polynomials. I erased that too. Okay, now I want to do the greatest common factor of a simple binomial. So let's do something like 4x minus 8. All right, really simple. So I'm going to take that, and now I'm going to factor out, right? So what I'm going to do is, what do they have in common? Well, they don't have x in common, so x is going to stay inside the parentheses. Just, you can see that already. And this one has 1 and 4 and 2 and 2. And this one, just so you can see, I hope you can already see it, and this is 1 and 8 and 2 and 4. And I can already see that they share, their greatest common factor is going to be 4. So to factor out this polynomial, I'm going to do this. I'm going to take 4. I'm going to place it outside of the parentheses, which leaves x inside the enclosure of the parentheses. And if I factor out 4 from 8, that leaves me, what's 8 divided by 4? Well, it leaves me a negative. I'm going to leave this because that's I didn't factor the negative out, so a negative's going to stay in, -2. How I can also now double check, so this is it. This is it simplified. This is as far as I can go with this expression. And how I can double check it to make sure I'm correct, and I believe he showed that on the video too, is that you do the multiplication. So distributive property here. 4 times x is 4x. 4 times -2 is -8. And is that the same as that? Yes, it is. And so that's a simple way to do that. I think, let me look at the homework and see if there's anything really difficult. Oh, we've got some weird ones. So let's try a weird one. Let's try a weird one, like we're going to simplify, let's say, x to the, it doesn't maybe need to be even. So on these ones, on their homework, they don't have a parentheses, and that's fine. You can just add the parentheses in. I just did that for just so you can see what's happening and containing it. X to the 5th minus, let's say minus 8, again, x to the third. Oh, wow, that's a little different. So what are we going to do? Well, we're going to find what is the common factors here. And again, I'm not gonna factor this out. You can factor it out, but you can hopefully see, right, that x to the 5 and x to the third, that x5, x to the 5th power contains x to the 3rd power. So I can take x to the 3rd power, and that's a common factor for this because it's x. Think about it. X times x times x times, if I was factoring it out, this is what it would look like. All right, x, yeah, and times x. There's 5 x's there. This x to the third would be x times x times, it looks like a plus, but times x, yeah, and so there's 3 of them, and there's 3 of them here, so I can do that. And so then I have, now have x to the 3rd power outside of the parentheses. Inside will be x squared, because I have 2 left, minus that 8, because I couldn't factor out the 8, and that's it. So this is, I believe, my answer simplified. Now I can double check it by saying, what is x to the 3rd times x squared? Well, that would be x to the 5th, because we know if it has the same base, we just add the exponents when we multiply. That's when we multiply. And then this is going to be, what's x to the 3rd times negative 8. Negative 8, remember, it takes the sign in front of it. That's its identity. So it will be negative 8x to the 3rd power. And then I look, is this the same as that? Oh, yes, it is. So I've done my job. Hope that helps. Let me know. All right. Cheers.